Greetings all, and welcome to our conversation on regression. In this video, I hope to share some background on what's probably the broadest and deepest uh, technique that we cover in MBA 535 Unit B. We are definitely only going to touch the tip of the iceberg in our conversations, but we hope to give you a little bit of purview on some of the broader and more sophisticated techniques. We, um, well, I should say I go into this conversation realizing that some of you probably have some experience with descriptive statistics and regression. Some may be more advanced than others. Some of you may be coming into this content for the very first time. Hopefully, what will happen at the end of this unit is that everybody will be conversant with these techniques and these approaches. For the folks that have experience, I hope it will be a nice refresher in case you haven't been deep into this content in a long time. Maybe there'll even be a few nuggets that you were not quite aware of. For the folks that are brand new to regression, I know it can be a little bit intimidating, but hopefully by the end of the module, some of the mystery will be taken out of the technique, and you'll feel more comfortable using it because it's something that is a very powerful and versatile tool and is touched just about every aspect of our day-to-day lives. If we start with just a little bit of history, linear regression and particularly least squares methods go back over 200 years. Some of the very first applications of these techniques were in predicting planetary movements, right? So physicists and astronomers were doing these calculations by hand a couple of centuries ago and using it to predict some pretty impressive things. If you jump forward about 100 years, Sir Francis Galton did some work in refining these techniques and did some different applications, looked at how regression analysis and correlation coefficients could speak to the heredity of plants. Galton was an applied statistician, worked a lot in biology and genetics, has a bit of a checkered past and a maybe not so flattering reputation, but did do some impressive work with this mathematics and these statistics. He also worked with Carl Pearson, who is very famous in statistical circles for some refinements that he did in the regression field. And the Pearson product moment correlation coefficient is named after Pearson, along with several other tidbits and different odds and ends. So, they were part of really spreading this technique into a lot of different areas and provided a stable foundation for some of the more advanced techniques and applications that we use today. If you think about the natural sciences and the social sciences, there's very few fields that don't leverage regression techniques. It is a very ubiquitous technique that can be applied in a bunch of different situations. And we'll talk more about that as we move through the module. But, these things have been around for a while. This approach to understanding the relationship between variables and empirical observations, and they provide us an opportunity to do some really interesting things. The current incarnations, like I said, the regression techniques are very widely used. There's very few scientific endeavors that don't use regression, at least in part. And that's important, particularly for an MBA student, because we are expected to have a strong functional scientific background. We're also expected to be able to go into academic and practitioner literature to be able to research different phenomena and things that we are interested in, and to solve problems. And the more comfortable we are with the variety of regression techniques, the more effective we can be at doing that. And beyond just the ubiquitous nature of regression techniques, um, there are, basic regression techniques. There are certainly more advanced techniques, and then there are techniques that are regression based that are even more impressive. So if you have a strong functional knowledge of regression, and you are confident in the fundamentals of this technique, it opens a lot of doors as far as being able to look into primary research and make your own conclusions and be well informed. Um, this slide, this list is, part of a much longer list. I just pulled the first 16 observations from a website uh, that gives you some idea of all the different applications of regression. Um, when I was in graduate school, I took, I think, at least 5 different graduate level courses that were either fully based on regression or had large regression components in them. In particular, I took courses in um, linear regression, ANOVA, which is a special case of linear regression. My school actually had a fairly strong course in structural equation modeling, which is based on regression calculations. There are certainly many more than what's demonstrated here. So when you think about regression, think of it more as a family of techniques that have different capabilities, different strengths and weaknesses. It's it's really interesting that just about any type of data that you can collect, there is a specific type of regression you can use to look for relationships and to make forecasts and predictions. Very powerful. It would take a long time of really concentrated study to become really fluent with all the different flavors of regression. But for most of us, depending on the type of work we do, the type of research we're interested in, a lot of folks will pick one or a few areas and really do deep dives into those, and become really conversant with it. And that's what I invite all of you to do. Pick something that, or a couple of areas that you think will help support your career goals and your knowledge and research interests, and really dig into those. So now that we've got a little background, we've talked a little bit about where regression came from, what it looks like now. Let's talk about fundamentals, because I want you to have a good conceptual understanding of what we're trying to do with regression and what we're trying to convey in this module. What you see before you is a typical small academic data set. I pulled this from the Render et al. Text, and it gives you an example of a very simple, a very straightforward set of variables, set of observations. And the goal with regression is to look at the relationship between these two sets of observations. Ultimately, what we want to know is, can we predict one variable by using information from the other? But we have to start simply, right? Having something that you can do the calculations manually with, and something that you can visually interpret without too much difficulty is important, right? You don't teach calculus without teaching arithmetic first. And so what I strongly encourage everybody to do is, as you're working on your fundamentals, whether you're taking this course as a refresher or you're learning this material for the first time, take a deep breath, understand it for what it is. These examples maybe are not as realistic as you know they could be, but they do serve a pedagogical purpose, and will allow us to look at some of the things that we need to look at. If we look at a visual representation of this data and what we're trying to do conceptually, what we're saying is we've got all these observations, right? And we have all these data points. And what we're trying to do is come up with some approximation of the relationship between those variables. Now, for a lot of us, this is a review. But if it's not, it is still something that you need to take very seriously, because I can speak from personal experience. Both of my kids have started middle school, and they have been introduced to this type of data array and this type of relationship building in middle school, right? So, something that, maybe a few years ago was taught in high school, and a few years before that was probably taught in college, has now been pushed down to where younger and younger students are being exposed to this material, because it is something that they're going to see later in life. And if we want to be well informed, and we want to be aware of the different nuances of how information is portrayed and communicated, this is something that we need to be familiar with. Now, the good news is, if they can give the basics of this to middle school students, then any of us can learn it. And you'll hear me say quite often, if I can learn it, then anybody can learn it. And I believe that to be true. Just a couple of things to be aware of. If you think back to your high school days, and which were probably similar to my high school days, we talked about the scatter plot and that visual array of the data and the dots that we're looking at here. And we talk about the line of best fit, which is that blue line going through the middle of those dots, right? That bottom equation there, which is, not very intimidating for most of us, at least hopefully so. That gives us that relationship, right? That's the equation for that line. And we calculate that line using some fancy calculations, but they're simple enough in practice that we can all handle that. But I share this with you because I want you to realize this is something that is fairly intuitive, and it is at its core fairly basic. And we all have some experience with some aspect of this. And so, we can solidify that understanding and use it to branch out into more complex and more complicated applications. Those equations that I was talking about are given here, right? And to be sure, these are simple expressions for these calculations. There are, of course, as is often the times in academia, much more complicated means of demonstrating these relationships and talking about these calculations. But at their core, in their purest essence, this is what we're trying to do. And basically, it's some simple arithmetic, right? We're calculating several pieces, but those calculations are averages, and they are summations of simple relationships, okay? So, don't let this notation intimidate you. We're still doing adding, subtracting, multiplying, and dividing. So it's not too burdensome. Now, as I mentioned, we have our academic treatment, which is very important. We need to have simple structures, simple data sets, simple relationships, so that we can refine our techniques, we can practice the calculations and the relationships, and become comfortable with them. Now, once we are comfortable with it, then we can start looking at more complicated arrays. And this is a data set that I just pulled off the internet. There are several resources that we'll talk about later where you can find data to work with. but oftentimes actual data sets are a little bit more involved than simple, six observations on one variable and six observations on another. Most real data sets, if you're going to collect data and spend the time and resources to do that, then it makes sense to calculate or to capture as much data as possible at any one given time. And so what that means is you'll have multiple observations, usually as many as you can get. You'll have multiple variables. And you can see when you have a lot of different variables with many different observations, it's difficult to do some of the mental calculations and the visual techniques that we learn from the simpler data sets. Okay, it's not important that we know how to do all the calculations and things for this. We just need to realize that at a certain point, the mental burden becomes a little too much for us to have to deal with manually. Okay. This is an example of a more involved scatter plot. And you can see when you have multiple observations, visualization of the data becomes important. And there's certainly more sophisticated techniques for visualization, but we can't always rely simply on what we see. We need to be using techniques and using computer software and different platforms to help us make sense of the data. And we'll learn how to do that. And you'll become more comfortable with that as time goes on. But remember, you got to walk before you can run. And that's what we're trying to get at with this class. Now, we've talked a little bit about the history. We've talked a little bit about the current incarnations. We've talked a little bit about why we do what we do in the class as far as different calculations and what we can expect in real life. I wanted to share quickly with you just a couple of examples of what this looks like in practice. Now, for a lot of us, there'll never be a need to really do a deep dive into academic literature and spend a whole lot of time in journal articles. But from time to time, we will have an interest in looking at primary research material. And when we do that, it'll be helpful to understand what we're looking at and how the regression techniques and other techniques that we cover are presented in practice. Now, the example that I have here, this is just a random table I pulled from a journal that I had on hand, and it shows a very simple model building approach to regression. When you're reading the Render et al. Text, it'll talk about model building and how you incorporate additional variables at different stages of the regression. And this is what it looks like when they present that material in academic literature. You'll see regression coefficients in the various columns. You'll see the columns get a little larger as you go from left to right. That means they're adding additional variables at each stage of the regression. The asterisks there beside the numbers, that's giving you some indication of statistical significance, right? And there's always going to be a ledger that tells you what those different symbols mean. In this one, the 3 stars by a particular value indicates it's statistically significant at the 99% level. You'll get more comfortable reading and understanding that data, but I wanted to give you a picture of what this looks like. So even now, as you start doing research for different projects or looking for different pieces of information, when you see something like this in a journal article, you won't be immediately turned off or intimidated by it. This is simply, the academic publication standard for publishing regression results. And you can see down at the bottom there, you have your R squared, your adjusted R squared, and your N for this information. And that's all fairly common and fairly standard in most academic research. Now, years ago, people would use regression as the primary analysis analysis tool for different studies. Now there are certainly more sophisticated techniques, but oftentimes researchers will use regression to explore different relationships, and they'll often publish regression results, even if it's not the primary analysis tool, just because people are so used to seeing that in print, and it provides a level of comfort in allowing people to look for relationships between variables. Another example of a very common data representation that you'll see in the literature is the descriptives table and the correlation table. Now, in this table, what we're seeing is the correlation coefficients between the different variables in the study. This tells us what the relationship is between any two sets of variables. Okay, they also use these types of tables to give some of the descriptive statistics, right? You'll have the range, the mean, standard deviation down there. Same convention, you see the asterisk by the numbers. That is indicating the statistical significance of those correlations and those coefficients. Again, this is something that you're going to see quite often. Regardless of the analytic technique, you'll often see a correlation table that provides this information. This is very helpful if you do certain techniques like structural equation modeling. You can actually do your own analysis based just on these values, depending on some of the techniques. And so that is very important for the replicability of research that academics value so highly. So another thing to be aware of, to not be intimidated by, just get used to looking for this information. And by the time you get to the end of this module and had a chance to read chapter 4 on regression, this should give you a good understanding of what these relationships are and why this information is important. Now we're going to switch a little bit to some additional resources. Like I said, regression is probably the widest field that we cover. It has so many applications and so many topics. You couldn't possibly cover it all in a single module, and you certainly can't do it in a single class. But I did want to give you a couple of resources that you could look into for more advanced graduate treatments of regression. The first one we have here, the Applied Multiple Regression Correlation Analysis for the Behavioral Sciences. When I was in graduate school, one of the very first regression courses I took was a multidisciplinary class. We had folks from the social sciences, we had folks from social work, we had folks from business, all kinds of different disciplines. And we were all taking the same course because these techniques are so widespread. This book is one of the most well-respected treatments on linear regression, and it does a really good job of helping you understand the conceptual and the technical basis for regression and how it can be applied in the behavioral and social sciences. It's been around for a long time. It's got several editions out. If you find an opportunity to get your hands on a copy of this book, I highly recommend it for your personal library. It's got a lot of information in there. It is a graduate level text, but it's got some really good examples in it, and it will really sharpen your ability to do regression. Another class that I took that was similar to that had that multidisciplinary interest was focused on ANOVA, which is a special type of regression analysis. And the textbook we used in that class was Designing Experiments and Analyzing Data. This is really good because not only does it talk to you about some of the regression techniques and special cases for that, and it does it in a lot of depth, but it also talks about how you can design research and some of the philosophy and conceptual background that you need to be aware of and concerned with if you're developing your own research paradigm. So this is another really good technical text that if you're really interested in this stuff and you want to get to some more advanced concepts and into some more of the more technically advanced components, this is a good resource to check out and to add to your library. Finally, for those of us that are not as technically savvy, we're not as mathematically or quantitatively advanced. Um, if you want to have just a good conversation, a good conceptual description of what statistics are and why we use them and what they're intended to do, this Abelson book, Statistics as Principled Argument, is a really nice resource. It's a very short book, but it's a non-technical treatment of statistics. But if you've ever been curious about, okay, why do we do what we do? How do we know that all these calculations that we're doing make sense? And the relationships that we think we're exploring really have some philosophical underpinning. This is a really nice text. Well, it's not really even a text. It's just a nice book to pick up and read through. You can be a casual user of statistics and still enjoy this book. It comes highly recommended, and I've known a lot of colleagues that have read this book and found a lot of value in it. So I thought I would recommend it to you all. That does it for the conceptual background. I could spend a lot more time going on about this and talking about different flavors of regression and how they're used and things like that. But I'll leave that to the folks that are interested. Obviously, if you have a particular interest and you want to talk more about it, reach out to me. But good luck with your exploration of regression, and I hope you find some value in it.